तिथे 3 जागी हे येतात. Are you able to see board properly? Hello?
Yes, sir.
Good, very good. Okay, everyone, good morning. All पृथ्वी तल के लोग और ऑनलाइन आकाश में के लोग, we are here to discuss a very interesting subject. तो सब्जेक्ट का नाम लिखना बेसिक इलेक्ट्रिकल इंजीनियरिंग. बेसिक इलेक्ट्रिकल इंजीनियरिंग. बेसिक इलेक्ट्रिकल इंजीनियरिंग. Okay, students, we'll start with one very basic question. See, whatever electricity that we are getting in terms of voltage, is it AC or is it DC? All of you are AC.
AC.
AC, very good. So basically, AC stand for alternating current and DC stand for direct current. So our first topic, so make a title, syllabus, DC circuit. DC circuit. DC circuit. Okay. Second topic is single phase AC circuit. Single phase AC circuit. Single phase AC circuit. Now the maximum weightage is given to these two topics. Maximum weightage is given to these two topics. No doubt other topics are also very important, but from examination point of view, these are the highest weightage topics. These are the highest weightage topic. Topic number 3 is three-phase AC circuit. Three-phase AC circuit. Topic number 4, single phase transformer. Single phase transformer. Single phase transformer. And topic number 5 is electrical machines. Electrical machines. तो बच्चों यहाँ पे होगा 3 phase. It is not 3 minus pi. What is this? 3 phase. What is this? So it is not 1 minus pi. It is not 1 minus pi. It is what? Single phase. What is this? Three phase. So here you have got three phase motor. Here you have got single phase motor, and also you have stepper motor, and you have DC machines. DC machines. So, DC machines. Okay. Now listen carefully. IA1 20 marks. IA2 20 marks. IA2 20 marks. Now this is a separate head of passing. Come in, beta. So IA will be IA1 plus IA2 divided by 2. So out of 20, minimum 8 you should get. But I expect you to get 20 out of 20 because it is very interesting. Chota portion hota hai. Very easily we can score. Because now you are coming from ocean of 11th and 12th. बहुत सारी अंदर जाके आए हो, so you are seeing the vast thing. Now only challenge here will be the time. Now we have got a time of 3 months or 4 months. Luckily you are here for vacation batch. That is a great advantage for you in Vidyalankar. So that will help you to prepare all the subjects well before time. Okay. Now you have 25 marks term work. You have got 25 marks term work. Meaning whatever practicals you will do, whatever assignments you will write, okay, again a separate head of passing. मतलब अलग से इसमें 25 में से 10 आना चाहिए. Okay, then 25 marks oral. Now here somehow हम लोग थोड़ा सा वीक हो जाते हैं. Either we are little bit shy, or sometimes we don't understand the subject to the depth and we are not able to answer the questions. Now you must be knowing, you have given oral examination before. Sometimes we get nervous here because here there will be an internal examiner who will be teaching you, and there will be external examiner, and both of them will judge you for this. Okay, again, out of 25 marks you should get minimum 10. And EAC, end semester examination. Okay, end semester examination is for 80 marks. Okay, again out of 80 minimum 32 we should get. तो अगर कोई चाहे तो एक ही सब्जेक्ट में 4 KT आ सकते हैं, 1 2 3 4. और अगर कोई चाहे out of this 150 he may score handsomely and go beyond 140 145 and get a very good pointer, very close to 10, and that should be your aim. Because you must have heard there is a lot of competition for getting good jobs. If your pointer is good throughout all 8 semesters, semester 1 to semester 8, you are eligible for a very good company. मतलब हम तो ये सोचेंगे नहीं 10 मार्क 32 मार्क 8 मार्क. हम क्या सोचेंगे कि for BEE out of 150 how I will be more than 140. Possible. You are here and you are with Vidyalankar, you are in vacation batch, you are ready to learn the things, you are ready to work hard, because once you finish all the portion in vacation batch, you are a little bit relaxed because you know maths, you know mechanics, you know BEE. Then whatever work given in the college, very easily you can do. You can write assignments, you can write journals, you can do quite well here. you can do quite well here. But ऐसा नहीं कि you have to stop. You are also allowed to attend again in the regular batch. What you can do, you can come sit, solve extra questions, torture us. Sir, ये तो आता है मुझे. Sir, मुझे एक difficult वाला solve करना है. You can do that. Means with the same fees, you can attend the entire course one more time. So that is a very, very great opportunity. Anyone, any doubt about syllabus?
Sir,
And bolo beta.
what is IA?
IA stand for internal assessment.
Okay, thank you.
IA stand for internal assessment.
हेलो सर.
Go ahead beta, I'm there.
सर ESC क्या है?
End semester examination.
अच्छा, ओके. एंड वो टीम वर्क और जो ओरल है वो टीम वर्क
टर्म वर्क
हाँ, टर्म वर्क उसमें से प्रैक्टिकल्स इंक्लूडेड है.
उसमें क्या रहेगा, you have to perform practicals and whatever practicals you will perform, your teachers will grade you. He will ask some questions and 10 experiments you will be conducting and he will be giving you final marks out of 25. So here you will be assessed for your assignment, journal, practicals. So can you see this a big number? So everyone ready for this journey? हाँ सेम मतलब IA1 होगा after 1 month, IA2 होगा after 1 month, and after 3 months ESC, oral, and all these things. This you have to submit at the end of the semester. You have to certify.
Sir, these IA1s are like unit test.
Unit test, exactly. So बच्चों, सबसे important point, because you are in vacation batch, so always I say you have started on a very good note, because you can see all these things a bit difficult to do in regulars. कर सकते हैं but difficult. But वो अगर vacation batch में आप ये सब कर लेते हो, it will be a great advantage for you. Okay, so बच्चों, I will start with one very basic question. What do you understand by AC and DC? AC stand for alternating current and DC stand for direct current. So whatever discussion I will do today will give you the entire understanding of your syllabus. I will talk about DC, I will talk about AC, I will talk about AC single phase, I will talk about AC three phase. I will talk about transformer, I will talk about machines, motors and generators. So after this initial discussion, you will get a great confidence. अरे हाँ, सब टॉपिक्स अभी मुझे पता है कि बेसिकली क्या है. Then हर एक टॉपिक के अंदर जाना है. Numericals, theory, understanding, some cross questions we have to do. So whatever discussion we are going to do, it will play a very important role. It will play a very important role. Okay, can I go ahead?
हेलो सर.
go ahead बेटा.
सर वो इलेक्ट्रिकल मशीन्स में वो 3-5 मोटर है.
3 phase motor, 3 phase motor, 3-5 नहीं है, it is 3 phase motor. तो जिन्होंने 3 Idiot देखा होगा उनको याद होगा, राजू रस्तोगी explain teacher how that motor start. तो यहाँ पे करना है, थोड़ा सा इलेक्ट्रिकल बताना है हमको कि there is a rotating magnetic field. So here is also a motor. बच्चों, all online people and offline people, कि what motor do and what generator do. एक मैं बताता हूं, एक आप बताओगे. Generator converts mechanical energy into electrical energy. Everyone understood? Generator converts mechanical energy into electrical energy. Now question to you, what motor converts?
Electrical energy into mechanical energy.
मतलब आपका जो फैन है, is it a motor? आपका जो एसी के अंदर कंप्रेसर है, is driven by a motor?
Yes.
आपका वॉशिंग मशीन है, वॉशिंग मशीन के अंदर it is a motor. Yes. Then रेफ्रिजरेटर है, कंप्रेसर है, मोटर. Now see how many questions very close to you. ओरल में पूछा जाएगा कौन सा मोटर है, एटलीस्ट इतना तो बताना चाहिए, इट इज अ सिंगल फेज बिकॉज वी नीड लेस मैकेनिकल पावर। तो जहां पे कम मैकेनिकल पावर चाहिए वहां पे हम लोग सिंगल फेज मोटर यूज करेंगे, और जहां पे ज्यादा मैकेनिकल पावर चाहिए, फॉर एग्जाम्पल आपकी सोसाइटी का वाटर पंप पंपिंग द वाटर फ्रॉम ग्राउंड टू अपस्टेयर, 3-phase motor. Lift in your society is also driven by the motor, but एक छोटू से मोटर से काम नहीं चलेगा, you need 3-phase motor. तो oral will be very interesting in BEE because BEE is all around you, single phase, 3-phase, all these things, train, transformer. Okay, a very interesting example. Online student, please listen, you also listen carefully. Okay, आपका जो मोबाइल फोन का चार्जर है, what is inside that charger? अब मैं बताता हूं, मैं पहले आपको फाइनल करता हूं कि इनपुट क्या है, आउटपुट क्या है। इनपुट इज अ सिंगल फेज 230 वोल्ट एसी 50 हर्ट्ज। इनपुट इज सिंगल फेज 230 वोल्ट 50 हर्ट्ज जब तक आप यूएस में नहीं हो, जब तक आप इंडिया में हो। वंस यू फ्लाई टू यूएस, 50 के बदले होगा 60 हर्ट्ज, 230 के बदले होगा 110 वोल्ट्स, अगेन डिफरेंट स्टैंडर्ड। जब तक आप इंडिया में हो, सिंगल फेज 230 वोल्ट 50 हर्ट्ज। और चार्जर के आउटपुट में क्या आना चाहिए, ध्यान से सुनना, अप्रोक्सीमेटली डिपेंड्स, आईफोन 23s 23 अल्ट्रा प्लस यही फोन यूज करते हैं आप लोग ना, आईफोन 14 मैक्स या वीवो, ओके ओके, विच एवर फोन यू यूज, अप्रोक्सीमेटली 4.7 3.7 और 4 वोल्ट, approximately 4 volt, approximately 4 volt DC, frequency 0. Do you agree? What is the frequency of DC? 0. What is frequency of DC? AC कैसा होता है, साइनसॉइडल, साइकिल्स होते हैं, DC. A very simple question asked in oral examination, what is frequency of DC? Your answer should be 0. अब देखो, whatever small experience I have, I will try to touch all those things. I will touch this also, I will touch this also, I will touch this also, I will touch this also. Okay, तो आपको I will try my best to give you all aspects of this. मतलब आपको सिर्फ थोड़ा सा मेहनत करना पड़ेगा. Hope everyone is ready. Okay, थोड़ा सा कैलकुलेशंस एक्स्ट्रा करना पड़ेंगे. कोई अलग मेथड से बोला तो, अगर अलग व्यू से आ रही, ये सम सुपरपोजिशन से किया है, आई एम ट्राइंग विथ थेवेनिन्स, different methods. So this is a journey and hope everyone is ready with me for this very nice journey, because मैंने अभी अभी जो जो बोला, मोटर, सिंगल फेज, 3 फेज, somehow you can relate it with your day to day life. Somehow you can relate it to your day to day life. Everyone agree with this? Okay, anyone, any doubt? Online people?
Sir, I had a doubt.
Go ahead,
You have
beta.
this vacation for like 1.5 month maximum. How many
Correct.
chapters will be practically complete? Like you
all entire syllabus. Don't worry.
Okay.
All entire syllabus. Okay. Okay, we'll start. So, bacha, don't worry. We have done this thing. We are doing this thing from last 30 years. So, don't worry about the syllabus. कि syllabus cover होगा नहीं होगा. It will be definitely covered. It will be definitely covered. आपको एक तो पता चला होगा. I believe you people talking with me instead of only I talking. Instead of only I talking. बच्चों, to start with, तो जो भी डिस्कशन होगा, it will touch all the topics. It will touch all the topics. So when today you will go from this lecture, you have got understanding of all the topics and basics of some topic like DC circuit. इतना मेरा आज का intention है. I do believe in utilizing each and every minute so that it will be helpful for you. तो बच्चों, tell me, Which type of supply is this?
Alternating supply.
Alternating. Very good, very good. So can I say this is AC? Okay, what AC stand for?
Alternating current.
Alternating current.
Alternating
Current.
current. Very good. Alternating current. Okay. Tell me, what is this?
Direct supply.
This is
DC.
DC. Again, direct current. Very good. Direct current. Everyone agree with this? Everyone agree with this? Okay. Now, let me know, because Hamisha, there will be something interesting. Okay. How we will define the AC? A very raw definition. Voltage or current that varies with respect to time is called as alternating current. Everyone agree?
Yes.
But this is not complete definition. Something is missing in this definition. Something is missing in this definition. देखते हैं क्या मिसिंग है. हमको लगा हमने लिखा, अरे सर मैंने डेफिनेशन लिखा, मुझे आधा मार्क काटा. क्यों काटा ये भी मैं आज बताऊंगा. हमको तो लगा ये कंप्लीट डेफिनेशन है. A current or voltage that is alternating with respect to time is AC. कोई बोलेगा एग्जांपल दो, तब बोलेंगे सर जो वोल्टेज हमारे घर पे आता है दैट इज AC. Whatever ECG we get from that ECG machine, that is AC, because that is varying with respect to time, though not so nicely, but it is changing with respect to time. It is changing with respect to time. Okay. And what is definition of DC? A voltage that remains constant is DC. Okay. अब देखते हैं कि why it is not sufficient. Okay. What is this supply? Is it AC or is it DC? Looks like AC.
DC. DC.
Looks like AC, but actually it is DC. Why? This is output of a full wave rectifier. This is output of a full wave rectifier. अब बोलेंगे rectifier कहाँ से आया? अब वापिस will go to your mobile phone charger. Input क्या है? 230 volt. Now 230 will be reduced to 6 volt or 5 volt. Step down by using single phase transformer. I touched that topic. क्या किया मैंने? ट्रांसफॉर्मर से वोल्टेज को 230 से कहां तक लेके आया? 6 वोल्ट. और मैंने नाम क्या बताया उस डिवाइस का? सिंगल फेज स्टेप डाउन ट्रांसफॉर्मर. अब बोलेंगे जैसा स्टेप डाउन होता है वैसे स्टेप अप होता है? होता है. क्यों नहीं होता? ओके. बट स्टिल इट इज एसी. I need converter that will convert AC to DC, but I won't get directly. First, I will get this step. This AC will be converted to this DC, and by using filter, इसके अंदर जो रिपल है उसको रिमूव करके क्या मिलेगा? DC. So, what are the main blocks in your mobile phone charger? Step down transformer, rectifier, filter. Okay. Is it very close to you? Every day you use? Okay. So hope when examiner will ask this question, you will not think it is out of syllabus, because it is related to your day-to-day life. It is related to your day-to-day life. Now tell me, is it AC or DC? DC.
DC.
Can I modify
DC.
definition now? Can I modify definition now? AC is alternating current, alternating quantity that varies with respect to time and have both polarities. And have both polarities. What about this? What is DC?
Single polarity.
Positive
Only one
polarity.
polarity, either positive or negative, either positive or negative. So this is AC, this is DC, this is also DC, though not pure DC. This is pure DC, this is pulsating DC. मतलब इसको और प्रोसेस में डाला जाएगा. कौन सी प्रोसेस में जाएगा? फिल्टर. Okay, so what is DC? DC is a current or voltage that remains constant and have only one polarity. Because sometimes this definition may not be fulfilled. It is not constant, but it is still DC. It is still DC. Understood? वो half mark आ जाता है. Units. This incomplete definition, Kirchhoff's law. Sum of all the voltages in a closed electrical circuit is 0. Sometimes you may get 1 mark or 0 mark. क्या missing है? Algebraic. Algebraic sum of all the voltages in a closed electrical circuit is 0. आप बोलेंगे सर मैंने सब पूरा लिखा था फिर भी मुझे 0 मार्क मिला. But is that algebraic very very important? Is that algebraic very very important? And here we are going to do that. Okay. So please feel free. अभी तक जितना discussion हुआ, are you comfortable with concepts? Okay.
Sir, can you
Speed.
repeat the definition of alternating DC?
हाँ, alternating का बच्चा definition ऐसा होता है, and AC voltage is a voltage that varies with respect to time and have both the polarities. And have both the polarities. DC is the direct current which is constant with respect to time and have only one polarity. Am I right, bacha? Am I clear?
Yes, sir.
Okay, bacha. So this is what this. Bacho, a very interesting question to you. आपने बोला कि हम लोग हमारे घर पे जो ट्यूबलाइट है, वॉशिंग मशीन है, जो भी है, टीवी है, सब कुछ ऑपरेट करते हैं एसी पे. सब कुछ ऑपरेट करते हैं एसी पे. व्हाई नॉट डीसी? वेरी ओपन क्वेश्चन. वेरी इंटरेस्टिंग. इसमें बहुत सारा, इसमें हम लोग बहुत इंटरेस्टिंग वे तक जाएंगे, लेवल तक जाएंगे.
Because AC current can be traveled to longer distances.
वेरी गुड. एक आंसर आया, हीट. हीट में बी द प्रॉब्लम. हीट में बी द प्रॉब्लम. ओके. एक आंसर आया कि AC can travel a longer distance. AC can travel a longer distance. Now question is,
So different appliances require a different voltage and current.
no. That is not correct. हम
So
जाएंगे.
DC में एक अप्लायंस बंद हो गया तो फिर पूरा सारे अप्लायंस बंद हो जाते हैं.
That you're talking about sales.
Sir, DC current is constant over long time, so it is very dangerous.
Dangerous. Very good.
Sir, again उसको step up, step down कर सकते हैं.
Good. Lot of very interesting.
Circuits are cheaper than DC.
Sir, AC can change its voltage up and down for any appliances.
Good. Okay, हम लोग थोड़ा, हाँ बोलो बेटा, go ahead.
So our appliances finally use DC current only, right? AC is converted to DC, and our appliances are using DC.
No. Only your mobile phone charger gives DC to your battery. All appliances work purely on AC. Tubelight works on AC. Fan works on AC. जो आपने क्या किया? आपने सोचा कि जो रेक्टिफायर वाला कंसेप्ट है वो सब तरफ नहीं लगेगा.
सर
It will be on. हाँ बोलो, go ahead बेटा.
वो डीसी हर एक अप्लायंस के बाद कम हो जाता है उसकी
पावर होगी. ठीक है. There are a lot of very good answer. I will go little bit. थोड़ा सा मैं पीछे चला जाता हूँ. नाम देता हूँ तो आपको थोड़ा सा इंटरेस्टिंग लगेगा और आपको याद भी आएगा. Who invented DC? थॉमस एडिसन. सुना है नाम? थॉमस एडिसन. तब तक एसी का दूर दूर तक नामो निशान नहीं था. And he was having bulb, he was having motor, everything he was having. Means I can design any load that will work on DC that right now working on AC. तो लोड कभी भी प्रॉब्लम नहीं करेगा, आप पर्टिकुलर सप्लाई के लिए लोड डिजाइन कर सकते हो. बेस्ट एग्जांपल वाज, अगेन आई विल गो इन फ्लैशबैक. आप जो ट्रेन में से ट्रैवल करते थे, इट वाज यूज्ड टू वर्क ऑन डीसी. दैट टाइम फैन था, बल्ब थे, ट्यूबलाइट्स थे, मोटर्स थे, सब कुछ वर्क कर रहा था. मतलब देयर इज नो प्रॉब्लम in the operating load on DC or AC. Everyone understood? Okay. He faced some difficulty that is solved by Nikola Tesla. Have you heard about this? Tesla?
sir.
Yes, sir.
Okay. What he pushed कि you have to have lot of generating stations after each certain distance. मतलब आप डीसी एक लेवल तक ही ट्रैवल कर सकते हो, उसके बाद में आपको वापस एक स्टेशन लगेगा that will generate DC and that. But what he actually pushed, he said that instead of DC we can generate AC. Instead of DC we can generate AC. Then बोलेंगे what is the big deal? जो AC कर DC कर रहा है वही AC करेगा. But he proved that to transmit very large amount of power, current required will be very high. So instead of transmitting normal voltage and very high current, what you can do, transmit very high voltage and comparatively low current at the transmitting end, and at the receiving end again reduce voltage, get back your original current, and you can transmit electricity to any distance. And here comes the concept of transformer. Now what he insisted, कि at the transmitting end you can step up electrical voltage, and at the receiving end you can step down electrical voltage. But DC cannot work with transformer. Transformer works on a alternating principle. Even हम लोग थोड़ा सा ये भी देखेंगे, डीसी दिया तो ट्रांसफॉर्मर में गेट डैमेजेस. तो बच्चों, why AC is used right now? Because it can be transmitted over a longer distance. Everyone agree with this? Okay. अगर एग्जामिनर ने क्वेश्चन पूछा कि why you are using AC supply, why not you are using DC supply? So what is your answer? DC cannot travel over a longer distance, or any supply cannot travel over a longer distance unless and until it is step up at the transmitting end and step down at the receiving end. Now this step up is a step up transformer, and this step down is a step down transformer, and transformer works only on AC, and this is the reason to transmit electricity over a longer distance we use AC. Anyone any doubt about this? Okay. एक बहुत इंटरेस्टिंग डॉक्यूमेंट्री है that I will suggest you. War of Currents. लिख लो. War of Currents. American Genius. War of Currents. War of Currents. War of Currents. American Genius. AC versus DC. AC versus DC. ओके, अगर आप ये टाइप करोगे तो आपको एक दो तीन वीडियोस मिलेंगे, कोई भी एक वीडियो देख लेना जिसमें ये सब कुछ बताया है. नाउ इसमें टेक्निकल के साथ कुछ अदर एस्पेक्ट्स भी बताए हैं. यहाँ पे एक इंटरेस्टिंग चीज, हु वाज हीरो, टेस्ला और एडिसन? फॉर यू, टेस्ला. व्हाई नॉट एडिसन? ही इन्वेंटेड बल्ब. ही टॉक्ड अबाउट डीसी. he generated DC first time, so it is the DC which was generated on the earth first time, so more credit should be given to him. No, that war went into some unwanted thing. What Thomas Edison did, he said that AC is more dangerous than DC. See, during that particular interaction, what he did, he tried to convince government that AC is very dangerous, and it was used by his suggestion to kill the people who have got death punishment. नॉर्मल जो सप्लाई लगा के इलेक्ट्रिक्यूशन करके जो फांसी के बदले अल्टरनेटिव चाहिए था, तो व्हाट ही डिड, he said that AC is more dangerous, it can be used for this purpose, should not be used for normal household purpose, but it is very fine. Thanks to Nikola Tesla. Go to that documentary. Technical part मिलेगा ही आपको, but some human aspect, social aspect also you will get, that how scientists think, how technically they evolve, how as a human they evolve. Everyone clear about this AC and DC? Everyone very clear about this AC and DC? Okay. Topic number 1, DC circuit. We'll talk a lot about this. What is topic number 2? Single phase AC circuit. Topic number 3, three-phase AC circuit. Topic number 4, single phase transformer. Topic number 5, machines. अब ध्यान से सुनना, अब ध्यान से सुनना. Single phase 230 volt will be used for domestic application. Single phase 230 volt, उसको थोड़ा और मैं elaborate करता हूं. 50 hertz used for domestic application. Three phase 400 volt. Again, I will use little more detail. 50 hertz is used for industrial application. Everyone agree with this? Understood difference between single phase and three phase? Detail हम लोग जब टॉपिक के अंदर जंप करेंगे तब पता चलेगा. Now my question to you people is, आपके घर पे सप्लाई एसी होता है, इतना तो अभी की डिस्कशन से क्लियर हुआ, नॉट डीसी. बट डीसी अगर चाहते तो यूज कर सकते थे, लोड उसकी तरह से डिजाइन होता था. Now question is it single phase that comes to your place or is it three phase comes to your flat? See, my question is very specific. Right now in this room there is a supply. Similar supply is also available in your house or that flat. Is it single phase or is it three phase? Single phase.
Single phase.
Everyone agree with this? Okay. Now, very intelligent and very interesting question. Which supply enters to your society?
Three phase.
Which supply
Three phase.
enters to your three
Three
phase?
phase.
Three phase. Why?
Because
Because
water pumps are industrial this machines. Lifts and water pumps all are industrial machines. That's why maybe need.
Okay. अब ध्यान से सुनना. Very good answers. I'm very happy with that.
Lesser current.
Very good, very good, very good, very good. So बच्चों, I will answer this question. Now, what is my question? कि सोसाइटी में कौन सा सप्लाई आता है? Actually, मैंने इसका आंसर कर दिया था. When I talked about three phase motor and single phase motor, indirectly मैंने आपको आंसर बता दिया था कि जो आपका वाटर पंप है is pumping water from ground to, it is also a motor, that is also a motor, but the capacity of the motor is more. तो अगर मैंने वहां पे सिंगल फेज मोटर यूज किया तो साइज विल बी दिस मच. बट अगर आपने जाके चेक किया आज ही, साइज इज इतू सा, बिकॉज इट इज अ थ्री फेज मोटर. बिकॉज आप बोलेंगे सर पंप तो पंप है, उसको आप सिंगल फेज मोटर से भी ड्राइव कर सकते हैं, थ्री फेज मोटर से भी ड्राइव कर सकते हैं, तो आपने सिंगल फेज मोटर से उस पंप को क्यों नहीं ड्राइव किया? साइज ऑफ द मोटर विल बी वेरी ह्यूज, इफिशियंसी विल बी लो, लॉसेस विल बी मोर. ऐसा नहीं कि मैं मेरा वाटर पंप सिंगल फेज मोटर से ड्राइव नहीं कर सकता, कर सकता हूं, बट गॉट द डिसएडवांटेज, दैट्स व्हाई. ओके. सिमिलरली आप बोलेंगे सर लिफ्ट जो है उसको हम नीचे ऊपर करना है, सिंगल फेज मोटर बताओ काम खत्म. नहीं, इतना बड़ा मोटर हो जाएगा, बट मोटर होता है इतना सा. अगेन सेम इफिशियंसी, लॉसेस, पावर फैक्टर है, जो जो चीजें होती है 3 फेज में बेटर होती है. तो अंडरस्टूड व्हाट सप्लाई कम्स टू योर सोसाइटी. Okay, now question is, if this is the supply that comes to your society, if this is the supply that comes to your society, okay, so this is red, yellow, blue, और एक वायर होता है न्यूट्रल. This goes where? And this goes to what? Society, जहां पे एंट्रेंस है. Are you getting me? Are you getting me? तो सोसाइटी को भी यही सप्लाई मिलेगा. Okay, what is voltage here? 400 volt. What is voltage here? 400 volt. What is voltage here? 400 volt. तो जो आपके सोसाइटी में वाटर पंप है और लिफ्ट है, इसका तो काम हो गया, उनको 400 वोल्ट मिल गया. बट व्हाट अबाउट यू पीपल? यू पीपल डोंट वांट दिस. यू पीपल वांट 230. नाउ इसके लिए अलग से स्टेप डाउन करने का जरूरत नहीं है. There is one very interesting thing. There is some very interesting relation between 3 phase and single phase. This voltage is 230. This voltage is 230 volt. What is this voltage? 230 volt. What is this voltage? 230 volt. So if there are 24 flats in a society, what I can do? 8 flats will get red and neutral. 8 flats will get Y and neutral, and 8 flats will get B and neutral. सबका काम हो गया. Everyone understood? Now a very interesting situation in your society. A very interesting situation in your society. 16 flats का लाइट चल रहा है और 8 flats का लाइट कट हुआ. Can you guess problem? There may be एक फेस. नहीं, एक फेस चला गया. अब बोलते हैं ना, अरे एक फेस नहीं आ रहा है, एक फेस नहीं आ रहा है. नाउ देयर मे बी 2 रीजंस. एक बाहर से ही प्रॉब्लम है जहां से सप्लाई आ रहा है, या एक आपके सोसाइटी के अंदर जो 3 फ्यूज है उसमें का बी फेज वाला फ्यूज किसी ने बड़ा कांड किया, उसकी वजह से चला गया. आर यू गेटिंग मी? Then what electrician will do? First he will check कि किसके फ्लैट में प्रॉब्लम हुआ. MCB ट्रिप होने के पहले फ्यूज ट्रिप हुआ. MCB stand for miniature circuit breaker, and fuse is a electrical wire that melts. Understood difference between MCB and fuse?
Yes.
MCB ट्रिप होता हम क्या करते, जाके उसको अवॉइड करते, नहीं करने का, पहले देखने का मिक्सर में कुछ प्रॉब्लम है, हीटर में कुछ प्रॉब्लम है. Don't recharge the MCB because that facility is given to you. First cross check what may be the probable reason, then recharge MCB. But fuse chala gaya to you have to pull out the fuse, you have to replace the fuse and again plug in. Okay, fuse responds to very small time, very large current. अगर बहुत कम ड्यूरेशन का करंट आता है, मतलब within millisecond, microsecond, fuse will respond. What MCB will respond? It will respond comparatively long duration fault current. मतलब अगर शॉर्ट सर्किट या बड़ा फॉल्ट हुआ तो फ्यूज उसको पहले क्लियर करेगा और आपको सेफ्टी देगा आपकी सोसाइटी. और आपके घर में अगर छोटा मोटा मिक्सर जाम हुआ है, कुछ प्रॉब्लम है, तो आपका एमसीबी ट्रिप होगा. तो अगर सोसाइटी का फ्यूज चला जाता है तो समझ लेना किसी ने बड़ा कांड कर दिया. दिस इज हाउ थिंग वर्क्स. ओके, अंडरस्टूड? नाउ देयर इज अ वेरी इंटरेस्टिंग सिचुएशन, वन मोर इंटरेस्टिंग सिचुएशन. लिफ्ट के अंदर का लाइट चल रहा है बट लिफ्ट नीचे ऊपर नहीं हो रहा है. व्हाट इज द रीजन? एक फेज चला गया, एक फेज चला गया, एक फेज चला गया. अंडरस्टूड? सिंगल फेज, 3 फेज. एनी डाउट अबाउट दिस? ओके, व्हाट इज यूज ऑफ ट्रांसफॉर्मर? व्हाट इज यूज?
Input, lower input voltage into high output.
ओके, सबसे इंपॉर्टेंट, आपके मोबाइल फोन के चार्जर में ट्रांसफॉर्मर क्या काम कर रहा है? इज इट स्टेपिंग डाउन द वोल्टेज और स्टेपिंग अप द वोल्टेज? स्टेप डाउन. जो बड़ा इलेक्ट्रिकल वर्ड है जहां पे इलेक्ट्रिसिटी को पहले वोल्टेज को बढ़ाया जाता है, और बाद में एट द रिसीविंग एंड कम किया जाता है, वहां पे ट्रांसफॉर्मर का क्या काम है?
Step up.
At the step up at the transmitting end and step
step
down
at the receiving.
at the receiving end. Hope I touched all the topics. I tried my best. Any doubt, anything, we'll discuss. अभी बाद में whenever. Okay. तो हमेशा मेरा यही कोशिश होता है पहले लेक्चर में to make you comfortable with all these things, because numerical solution चलता रहता है, but उसके बीच में luckily we have got this type of things. Anyone, any doubt about this? If not, we can start with our first topic. If not, we can start with our
Sir,
first topic.
in three-phase and single-phase, what exactly is the phase?
Phase stand for live wire.
Okay.
Keep your
So,
receipts
and
ready.
why is it only three-phase? मतलब
हाँ, तो ज्यादा करेंगे. Higher the number of phases, higher will be the efficiency. But if I go beyond 3, the complexity will increase to a level so that we restricted ourselves to 3 phase. As you said, it can be 4 phase, 5 phase, 6 phase also, but the complexity will be more. That's why we are restricted our things to 3 phase. Am I clear, beta?
Yes, sir.
Okay. Okay, a small, okay. One more thing I want to share with you, because you asked this very interesting question. 3-phase motors are self-starting and single-phase motors are not self-starting. 3-phase motors are self-starting and single-phase motors are not self-starting. We'll wait for 5 minutes. Here we are collecting some receipts and all that. So be online for 4 or 5 minutes.
Sir,
DC is dangerous, तो उसका हो गया. Are you?
sir,
हाँ बोलो.
the single phase मतलब जनरेटर में एक ही कॉइल है? अगर ऐसा
नहीं, अगर सिंगल फेज जनरेटर होगा, तो उस जनरेटर में सिर्फ एक ही कॉइल होगी. बट अगर 3 फेज जनरेटर है तो उसके अंदर 3 कॉइल्स होगी. एम आई क्लियर?
यस सर.
बट हमको सिंगल फेज कहां से मिलता है? 3 फेज से ही मिलता है. हमको सिंगल फेज कहां से मिलता है? 3 फेज से ही मिलता है. बट देयर इज अ सिचुएशन, सपोज आई गॉट अ शॉप and I got a problem of frequent power cut. What is solution? I can have my own generator, and because my shop size is very small, I can have a single phase generator, और उस जनरेटर में सिर्फ एक ही कॉइल होगा. बट अगर मुझे सोसाइटी के लिए बैकअप चाहिए, इफ आई वांट बैकअप फॉर सोसाइटी, आपने देखा होगा कोई सोसाइटी में होता है, देन it has to be a 3-phase generator. मतलब अगर सोसाइटी का सप्लाई चला जाएगा तो still society works fine because they have got backup, they have got generator. What that generator will do? It will generate 3-phase supply and उस generator में होंगे 3 coils.
Understood, sir.
Very good. Okay, everyone note down topic 1. I'm very happy the way you people are interacting. So keep up the good work. because this makes we people very happy when you interact, when you ask or you put your own views. आप आपके खुद के views डालते हैं. Okay. Okay. Also, I'm going through your suggestions or questions on laptop. Very interesting questions. So again, जैसा कि we started with very basic thing. So I tried my best to give you that comfort कि entire syllabus is practical. मतलब आप जो पढ़ोगे somehow it is related to your day-to-day life, and definitely it will help you a lot. Definitely it will help you a lot. आराम से थोड़ा सा बेंच आगे ले लो. चलो बच्चों जल्दी अंदर आ जाओ. एवरीवन प्लीज बैक. हाँ हाँ हाँ, मतलब टॉपिक वाइज और योर टोटल 150 हाउ इट इज डिस्ट्रीब्यूटेड. हाँ, तो इंटरनल असेसमेंट 20 मार्क्स, दैट इज एवरेज ऑफ 2 IA1 plus IA2 divided by 2. Then 25 marks for term work, जो आप प्रैक्टिकल्स करोगे, जर्नल्स लिखोगे, that will be assessed. 25 marks for oral at the end of the semester, and 80 mark end semester exam. 80. तो टोटल कितना हो गया? 80 plus 20 plus 25 plus 25, a very huge amount. Okay.
Excuse me, sir.
हाँ, go ahead बेटा.
Can you please repeat what you said about fuses and MCBs?
हाँ, फ्यूज. बच्चा, हमारे घर पे फॉल्ट प्रिवेंट करने के लिए, एक्सीडेंट प्रिवेंट करने के लिए एक ट्रिपिंग स्विच होता है इंस्टेड ऑफ अ नॉर्मल स्विच. दैट इज कॉल्ड एज MCB, मिनिएचर सर्किट ब्रेकर, which will trip, and if you are comfortable that nothing is, there is no problem now, you can again switch it on. मतलब आपको कुछ रिप्लेस करने का जरूरत नहीं होता है. But there is also one fault clearing electrical appliance or device known as fuse. It will melt if current goes beyond the limit. Are you getting me? It is a alloy which melts if fault currents goes beyond. और आपके सोसाइटी का जो मेन बॉक्स होता है उसके अंदर क्या होते हैं? फ्यूज होते हैं, so that they will provide the protection. Am I clear, beta?
Yes, sir. Thank you.
Welcome, beta. Okay, we'll start. Okay, right. Series connection of resistance. Series connection of resistance. Series connection of resistance and voltage division rule. This I will call as VDR. This I will call as VDR. Voltage division rule. So बच्चों, whenever I connect my load in series, voltage will divide, current will be same. Voltage will divide, current will same. When I connect my load in parallel. Voltage will be same across all the element, but current will change depending upon the load. Okay, so this is R1, R1, R2. This is V. This is I. Sorry, I can't help. V2. कुछ लोग को थोड़ा सा होता है, वो थोड़ा सा एंजाइटी होता है. If someone put paper on the board, कोई इमली खाता है सामने अपने. Okay. Okay, बच्चों, V1 equal to, or first I will write what is R? R1 plus R2. Series में बहुत simple है. It becomes addition. Now how voltage will get divided? See, V1 equal to total voltage into the resistance across which I am finding the voltage. So the same resistance divided by sum of all series connected resistance. कोई बताएगा what is V2? V
R2 divided by equivalent.
R1. Very good. So what I'm saying, same resistance.
We had this thing in Kirchhoff law.
Beta, go ahead. No, this is not in parallel. Beta, I did not got your question.
These concepts were in Kirchhoff's law, no?
Correct. Okay, बच्चों, now you are eligible to solve one इतना छोटा concept, but we are eligible for your first Mumbai University sum. So I will put from Mumbai University paper. Question is, all are connected in series? Yes. Now this is V. This is 1 ohm. This is 2 ohm. This is 3 ohm. This is 4 ohms. Okay. If you want, you can put this symbol. Same symbol is there. Okay. अब ध्यान से देखना. This is V1 and this is V2. And question is, find V1 upon V and find V2 upon V. Okay, note down the question. Your first question in BEE. One ohm, 2 ohm, 3 ohm, 4 ohm. R1, R2, R3, R4. But don't name it unless and until I'm asking you to name it. Okay, what is difference between V and V1 and V2? V is the supply voltage and V1 and V2 are the voltages measured across 3 ohm and 4 ohm. ये बहुत important होता है because होता क्या है, sometimes this is connected like this and you get surprised कि वोल्टेज दिया है, यहाँ से दिया है, यहाँ से दिया है. You should understand this. So don't worry if it is connected to this, because this is a voltmeter which is measuring V1, and this is voltmeter that is measuring V2. Okay. So बच्चों, I will say method 1. Okay. What I will do, I will find I. I will find I. That is
V1 by V J by 10.
हाँ, correct. तो बच्चों,
V2 by V2 by 5.
okay, very good. So method 1, what will be I? I equal to V by R. So is it V by 10? Is it V by 10? Now, can I say V1 equal to I into 3? V1 equal to I into 3. So V1 equal to, what is I? I is V by 10 into 3. So V1 upon V equal to 3 by 10. Okay. What is V2? I into 4 equal to V by 10 into 4. So what is V2 upon V? It will be 4 upon 10. Everyone agree with this?
Yes.
Very good.
Sir, how the 10 value came for resistor?
1 plus 2 plus 3
For
plus.
resistor.
This is 1 plus 2 plus 3 plus 4. What is R? 1 plus 2 plus 3 plus 4. Now, see carefully what method 2 is. Now, I will not go this way. I will say V1 voltage across one of the series connected resistance equal to total voltage supplied into the same resistance across which I am measuring the voltage divided by sum of all series connected resistances 1 plus 2 plus 3 plus 4 10. Understood, Vidya? So this is my voltage division rule. I don't have to do this now. This we are doing previously. Now what we will be doing? We are using this direct. कोई बताएगा what will be the formula for V2 by VDR? V2 equal to total supply voltage into the same resistance across which I am finding the voltage divided by sum of all series connected resistances. So V2 by V equal to 4 by 10. Both methods are absolutely correct, because exam may sometimes if you are not able to recall this and you go by this conventional method, nothing wrong in that. So approach has to be a very positive approach. ऐसा नहीं कि आपको एक ही method सूझेगा. There may be a multiple ways to solve a particular sum. Note down.
सर
हाँ, go ahead,
फिर
बेटा.
से आप पता म्हणजे एक्सप्लेन करेंगे आप?
हाँ बोलो ना बेटा, क्या आप एक्सप्लेन करो.
फिर से पहले से.
हाँ बेटा. This is 1 2 3 4 connected in series, and question asked is find V1 upon V. Find V1 upon V and find V2 upon V. Find V2 upon V. So what I did, I found I, total voltage divided by total resistance. Total voltage is V. Total resistance is 1 plus 2 plus 3 plus 4, 10. Now, by using Ohm's law, V1 equal to I into 3. So V1 equal to I is V upon 10 into 3. So V1 upon V equal to 3 upon 10. Similarly, by using again Ohm's law, V2 equal to I into 4. So V by 10 into 4. So V2 upon V equal to 4 by 10. अंडरस्टूड बेटा?
यस सर।
हेलो, हाँ। और
Yes, sir.
मेथड 2 में है VDR, voltage across one of the series connected resistance equal to V into the same resistance across which you are finding the voltage divided by addition of all resistances. So V1 upon V equal to 3 by 10 and V2 equal to 4 upon 10. Okay. Can anyone tell me the second part of this discussion? इसकी जगह पे कुछ अलग वर्ड आएगा और इसकी जगह पे कुछ अलग वर्ड आएगा.
पैरेलल आएगा.
हाँ, तो पूरा सीक्वेंस मुझे पढ़ के दिखाओ, क्या आएगा?
Parallel connection of resistance and current division rule.
Current division rule. Can I say very confidently, in series voltage will divide, current will remain same. In parallel current will divide, voltage will remain same. इसके पीछे बहुत इंपॉर्टेंट चीज है. तो when you finish I will let you know. Everyone finished? Okay, right? Everyone right? Parallel connection of resistance, parallel connection of resistance, parallel connection of resistance, parallel connection of resistance, and current division rule. Okay, everyone, be very carefully. Okay, so this is V, this is I, this is R1, this is R2. Now this is I1 and this is I2. Am I right? Now 1 upon R equal to 1 upon R1 plus 1 upon R2. Am I right? Okay, so 1 upon R equal to, कोई बताएगा what is this? And what is this?
R1 plus R2.
Very good, very good. Now it will be R equal to R1 R2 divided by R1 plus R2. Okay, here comes now the role of calculator. अगर दो रेजिस्टेंसेस पैरेलल में हैं तो आप मोबाइल फोन यूज करके भी कैलकुलेशन करके मुझे बता सकते हैं. बट इफ देयर आर more than 2 resistances, 5 resistances in parallel, too difficult. There is a shortcut. See, अब मैं क्या करूंगा? Suppose there is a 5 ohm and 10 ohm in parallel. How I can do this on my scientific calculator? I will write 5 inverse, 5 का inverse, मतलब 1/5 plus 10 inverse, 10 का inverse, और जो आंसर आएगा उसका inverse. I got the answer. Means if there are many number of resistances in parallel, it becomes easy. हाँ बेटा, go ahead.
R1 and R2 are divided into 5.
नहीं, R1 is 5 ohm and R2 is 10 ohm, and I'm not going by this method. I'm in practical application where calculator is with me, 991 ES or ES plus. That should be with you on Saturday. आपके साथ ये calculator होना चाहिए by Saturday, because now without this it will be a bit challenging for you to do all the calculations. तो मुझे क्या करना पड़ेगा? ये सब कैलकुलेशन करना पड़ेगा 5 पैरेलल 10 करने के लिए. बट मेरे पास कैलकुलेटर, तो मैं क्या करूंगा? 5 इनवर्स मींस मैंने क्या एंटर किया 1/5 प्लस 10 इनवर्स What I entered? This. But I got 1 upon R1 plus 1 upon R2. I want R, inverse of answer. Now see the magic. If there are many number of resistances in parallel, it becomes very convenient. Are you getting me? Now coming back, what is I1? Current divided in first branch equal to total current into opposite branch resistance divided by sum of two parallel connected resistances. What is this? This is current division rule. Everyone agree with this? Okay. Similarly, can you tell me what is I2?
I into R1.
R1. What is special about R1?
Opposite.
It is opposite branch resistance. But see, in the denominator, I'm not using the same statement. I'm not saying all parallel connected resistances. I'm saying two parallel connected resistances. Question is, if there are more than two. देखो अभी गलती क्या हो सकता है? What common mistake that will happen? R1 parallel R2 parallel R3. Some student may end up writing I1 equal to I into, यहाँ पे कुछ लिखेंगे, अपोजिट ब्रांच कोई भी ले लेंगे और यहाँ पे लिखेंगे R1 plus R2 plus R3, which is totally wrong because CDR is strictly applicable. CDR is strictly applicable to two parallel branches. अगर मुझे फाइंड करना है R1 parallel R2 parallel R3 में, तो मुझे क्या करना पड़ेगा? This will be R1 और मुझे फाइंड करना पड़ेगा R2 parallel R3 and treat that as one branch and then apply CDR only for two branches. So what is basic difference between VDR and CDR? VDR is very interesting. Denominator, sum of all series connected resistances. But CDR, it is not sum of all parallel connected resistances. It is sum of two parallel connected resistances. Okay, note down.
Hello, sir.
Go ahead, beta.
So could you repeat the CDR method?
Beta. In CDR, current in one of the parallel branch equal to total current into opposite branch resistance. For I1, R2 is opposite branch divided by sum of two parallel branches resistances R1 plus R2. Similarly, what will be I2? Total current into opposite branch. What will be opposite to branch 2? R1 divided by sum of two parallel branches. Understood, beta?
Yes, sir.
Good, beta. Good. Go ahead.
So what happens if there are more than two branches? How do you
Then you have to reduce it to two branches. Okay. If it is R1 parallel R2 parallel R3 and you want current through R1, combine R2 and R3 as R2 parallel R3. Today we answered very interesting oral questions also with our syllabus. AC versus DC, single phase, three phase, all these things. Now, one more interesting question we will try to answer that is coming soon. Okay, question is, in your house, Please maintain a good long engineering notebook. Bring calculators. चाहिए तो बाद में आप देख सकते हैं. तो there are दो calculator के नाम लिखना. 991 ES plus 991 ES plus. Now this has become little bit absolute, but which is available is this. I prefer this. But अगर किसी के पास में पुराना कैलकुलेटर रहेगा, भाई का, बहन का, गर्लफ्रेंड का, बॉयफ्रेंड का, तो he or she will gift you. और इसे भी काम चलेगा. थोड़ा सा कुछ फंक्शंस कम है, बट पैर में चलता है थोड़ा सा. But this calculator has got some more functions than this. Okay, तो गर्लफ्रेंड को बॉयफ्रेंड को मना कर देना, डैडी से लेना अपने. Okay, now my question to you, a very interesting question, oral question. In this room or in your house, you got bulb, tube light, refrigerator, AC, everything. Here you have got. Are they connected in series or are they connected in parallel?
Parallel.
Yes,
Parallel. First half is correct, but इसका second half में जो answer आता है, it comes only half. अगर कोई बता देगा तो I'll be very happy. Why not in series? सब बंद हो गया. Resistance बहुत high हो जाएगा.
Sir, in series, if there is a failure on one end, the whole circuit goes down.
Goes down. तो और एक क्या? Same voltage. Very good. बच्चों, I will ask this question again in a different way. जैसा आपने बताया कि सर कोई एक लोड आपने बंद कर दिया तो अपने आप सब बंद हो जाएगा. But my question is, 10 के 10 लोड चालू रखा मैंने, तो भी none of the load will work. Voltage division rule. How much voltage is demanded by every load? 230 volt. If there are 10 loads, bulb, tube light, 230 is the voltage. हमने approximately assume किया it is getting divided by it is 10. तो हर एक लोड के अक्रॉस कितना वोल्टेज आएगा? 23. Will it create a problem? Huge problem. वोल्टेज कम होगा तो करंट ज्यादा ड्रॉ करने का कोशिश करेगा. तो योर आंसर इज करेक्ट कि कोई एक लोड बंद होगा तो सब बंद होगा, बट इनिशियली और इन फर्स्ट प्लेस नन ऑफ द लोड विल वर्क बिकॉज अक्रॉस ईच लोड वोल्टेज विल गेट डिवाइडेड एंड इट विल बी वेरी लेस which will not operate that load. Understood the complete answer? What you're thinking is correct because that is our normal logic. But थोड़ा हम लोगों ने जो पढ़ा होता है उसको हम लोग हमेशा ऐड कर देते हैं. Algebraic sum of all the voltage is equal to 0. Algebraic sum of all the current equal to 0. So try to understand that thing. Always try to remember. Everyone clear with this series connection, parallel connection? Okay. Again, as we are talking about your house, is any restriction on you that how many maximum bulbs, tube light, AC, refrigerator you can connect? Got my question? कोई आके रोकेगा एमएससीबी से या टाटा से या रिलायंस से, अरे तुमने ये एक्स्ट्रा एसी, बट समटाइम इट डोंट वर्क. गुड गुड. आपका और एक होमवर्क, यू विल टुडे सी योर इलेक्ट्रिसिटी बिल. आपका आज का काम क्या है? ओके. समवन मे हैव एक्सपीरियंस दिस सिचुएशन. सर मैंने 2 गीजर चालू किया 2 बेडरूम के और मेरा स्विच ट्रिप हो गया. 3-4 एसी चालू किया, स्विच ट्रिप हो गया. आर यू गेटिंग सिचुएशन? ओवरलोडिंग. बट वो स्विच को कैसा पता चला कि आपने 2 एसी चालू किया, करंट ज्यादा हो गया? तो टुडे वी आर गोइंग टू आई एम गोइंग टू टीच वन वेरी इंटरेस्टिंग कैलकुलेशन व्हिच विल टेल यू दैट व्हाट मैक्सिमम यू कैन कनेक्ट इन योर. नाउ आपका जो सैंक्शन लोड होता है अप्रोक्सीमेटली इज हाउ मच? 4.5 किलोवाट. Now P equal to VI cos phi. So P is 4.5 into 10 raised to 3 equal to 230 into I is unknown. Cos phi approximately आपको अभी पता नहीं है. I will take this approximately 0.8. Can anyone tell me I? मोबाइल पे किया तो भी चलेगा. मोबाइल पे किया तो भी चलेगा.
This 4.5.
एक मिनट. Is it? Okay, आप बताओ. Is it a good indicator? Is it correct, bacha?
Yes, sir.
Yes.
Okay. Now what this is telling you, this is what maximum you should draw from your sanction load. मतलब आप इतनी ही ट्यूबलाइट, इतनी ही बल्ब, इतनी ही एसी, इतनी ही हीटर एक साथ ऑन कर सकते हो. That will not exceed this. Okay, इसके लिए आपका जो सोसाइटी का जो स्विच बोर्ड है वहां पे एक 32 एम्पियर का सर्किट ब्रेकर होता है. तो अगर आपने 2 गीजर चालू किए घर पे, if you are having 2 bedrooms, separate bedrooms, definitely it will cross 32 ampere and it will trip. Then what you have to do? Switch off the geyser, again turn on, but एक ही टाइम एक ही गीजर ऑन कर. Understood? So next time when you are wiring, what care you have to take or what you have to think? आप बोलेंगे सर ठीक है, अभी तो हम लोग हमारे पेरेंट के साथ रह रहे, we are staying with our parents, whatever 1 BHK 2 BHK flat, but definitely when we will pass out and we will be having a very good package of 50 lakh or 1 crore per annum, we'll buy a very big apartment, 10 BHK, बड़ा हो गया थोड़ा, but only 1 wife. Okay, so बाकी चाचा मामा सब आएंगे. Are you getting me now? I'm staying in a bungalow. I'm staying in a big apartment where there are more than 3 bedrooms. आजकल है ना 3 bedroom, 4 bedroom, and definitely you don't want to restrict to this. Now what is the solution? Solution is you will go to supply company or you will apply to supply company and you will say that increase my power, increase my sanction load. Now this you will check. आप आज कहां पे चेक कर सकते हो? आपका इलेक्ट्रिसिटी पे. प्लीज डू रिवर्ट. ओके, चलते कभी कभी, बट रेटिंग अगर आपने, दैट इज आल्सो रॉन्ग. कभी कभी क्यों चलते हो उसका भी बोलता हूं कि जो एम्पियर आपने बैठाया है दैट इज नॉट करेक्ट. इट इज बैड फॉर योर मीटर, बैड फॉर योर वायरिंग, बिकॉज एवरीथिंग इज वायर्ड फॉर व्हाट? देयर विल बी ओवरहीटिंग, देयर विल बी बर्न. ओके, अगेन कमिंग बैक, what is the solution when you're staying in a 10 BHK apartment? When you're staying in a 10 BHK apartment, okay, then supply company may sanction you this depending upon your apartment. Now you can stay with that big apartment, okay, but supply company will not give you this with single phase. With single phase, this is what they will give. In that case, if you have got your bungalow, you have got your row house, you have got big apartment, then your supply will not be single phase. It will come through 3 phase only. और घर के अंदर आपको क्या करना पड़ेगा? जो आपका इलेक्ट्रिशियन रहेगा वो क्या करेगा? RN neutral to 2 rooms, YN neutral to 2 rooms, and BN neutral to 2 rooms. Definitely it will be costly. Definitely it will be costly. Understood? Now this is what happens with your day-to-day life. Now this you should know. This you should know. Everyone understood this? Okay, all sky people, आकाश लोक की people सबको समझ में आया? Online people, any doubt? हाँ? चलो. समझा. Okay बच्चों. तो बच्चों, one last question. What should be your MCB rating in your society? In your society electric box, it should be 25 ampere, exactly 25 ampere नहीं रखते, 32 ampere. If it is 64, you will be happy. अरे सर मैंने 2 गीजर चला लिया, कुछ नहीं हुआ. But are you in danger? Yes, because आपका वायरिंग किसके लिए है? इतने करंट के लिए है. And you may be drawing 32 or 40 ampere current. It will hit, it will damage, it will short circuit. Okay, so next time when you will look around your apartment, when you look about your supply, everything you will think about this. Okay. Okay, so before we proceed, okay, these are the wires that we see that are going around one transmission tower to another transmission tower. सबने देखा है? Everyone has seen this wires, बड़े-बड़े wires होते हैं. Now, a very simple question to you. Suppose there is a bird sitting on this wire. Suppose he or she bird sitting on the wire. She bird, suppose. So she will get a shock?
No.
No, sir.
No.
Clear? Okay. Now think about a situation. There is one more bird, he bird like Imran Hashmi nature. Will they get shock?
No.
No, sir.
No.
No.
क्यों? अभी तो now I will not detail that part. Just I will tell that कि सर्किट पूरा हो सकता था, but सर्किट पूरा नहीं हो रहा है. सर्किट पूरा हो सकता था because of this situation, awkward situation to see. That's why I drawn bird. Okay, why they are not getting shock? Because they are sitting on equal potential. This potential and this potential is not different. Are you getting me? But there is some very bad situation in some area where these wires are very close. And some monkeys catch this wire and they get shocked. Because in that case, circuit gets completed. या तो monkeys नहीं जा सकते because difference बहुत सारा होता है. But जहाँ पे distribution में RY भी बहुत नजदीक होते हैं, you may see some monkey getting killed. What is the reason? If he's holding only one wire, he will not get killed. But if he's holding two different supply, two different phase, there will be. Right now, circuit is not getting completed. कुछ लोग सोचेंगे सब circuit तो पूरा हो रहा है ना? No. Are you getting me? Okay. I will show you situation. What current will flow through this 10 ohm and this 10 ohm?
Parallel.
Situation. देखो, very interesting situation. There will not be any current through this 10 ohm. There will not be any current through this 10 ohm because it is connected to same point. So only 1 ampere current will flow. Are you getting me? Is it this type of situation? They are connected to what? Single wire only. There is no potential difference. But what is special about this? They are connected across a potential difference. Exam में सब कुछ draw नहीं करने का, oral में भी सब कुछ draw नहीं करने का, सिर्फ पूछा तो बता देने. Everyone understood? Okay.
No, sir.
Okay. Now write Kirchhoff's law. Kirchhoff's law. Kirchhoff's law. Kirchhoff's law. Kirchhoff's law. Right? Kirchhoff's voltage law. Kirchhoff's voltage law. Kirchhoff's voltage law. Kirchhoff's voltage law. Algebraic sum of all the voltages. Algebraic sum of all the voltages, algebraic sum of all the voltages in a closed electrical circuit, in a closed electrical circuit, in a closed electrical circuit is always equal to 0. Or algebraic sum of all the voltage sources and voltage drops in a closed electrical circuit, is always 0. Okay, in second definition, I'm talking more about what can be voltage. There are two possibilities of voltage. One is a source and one is a drop. Source is an active element. So voltage source or current source, these are active elements. They are having ability to supply power. But if I have resistance, inductance, capacitance in the circuit, they will only draw the power, consume the power. So they are passive element. Are you getting me? So right now in your house, your dad is active element and you are passive element. Dad is generating money and you are consuming a lot of money. Money is current. So what we are expecting as a parent, as early as possible, from passive element become active element. Understood difference between active element and passive element? Any source, voltage or current, is an active element because it is capable of giving energy, capable of giving power. And any element which is only dropping or consuming power, resistance, inductance, capacitance, is a passive element. समझ में आया? Okay. Now, which voltage should be considered positive and which voltage should be considered negative? Right? Sign convention. For KVL. Sign convention for KVL. AC बंद करना है, ठीक है? हाँ? Sign convention for, थोड़ा पीछे बैठेंगे तो भी चलेगा, तो AC नहीं आएगा. AC सेंट्रलाइज है, थोड़ा बोल देना बाहर, थोड़ा AC कम करने के लिए. Okay. बच्चों, which voltage should be considered positive or negative? इसके लिए बहुत ही इंटरेस्टिंग assumption होता है. Let's see what is that assumption. I may come across a voltage source having this polarity, or I may come across a voltage drop where current is flowing in this direction having this polarity. Understood what is the difference between this voltage and this voltage? This is also voltage which is V. This is also voltage which is IR, but this is voltage of a voltage source. And this is voltage of a passive element. It is a drop. Understood? Okay. आप बोलेंगे sir, we may come across exactly opposite voltages, जिसमें there may be negative first and there may be positive. So I may come across this type of voltage, or you may say that, sir, I may come across a resistance in which current is flowing in the opposite direction. Because of this current, there will be voltage drop, and what we mark, जहां से करंट एंटर करता है वी मार्क एज अ पॉजिटिव, और जहां से करंट निकलता है वी मार्क एज अ नेगेटिव. अगेन दिस इज understood, two set of voltages, either this or either this. Again, what is difference between this and this? This is the voltage of a voltage source and this is the voltage drop. There is the voltage drop. So this is the active element, this is passive element. अब ध्यान से सुनना. Now when we go in garden, conventionally we jog in clockwise direction. But अगर किसी स्पेशल आदमी को देखना है बार बार तो हम लोग उल्टा भी कर सकते हैं. That is your choice. But this is the normal convention. मतलब कोई आपका खास आदमी जॉग कर रहा है, हाँ, तो आप कैसा बोलेंगे सर उल्टा जाते तो बार बार दिखेगी वो तो अच्छा लगेगा. Now this is called as trace direction. This is called as trace direction. Now what is our assumption of trace direction? Clockwise. Again, is it compulsory? No. You may travel in a circuit in clockwise. You may travel in circuit in anti-clockwise because balance will be there. जब आप clockwise travel करेंगे plus minus मिलेगा आपको. जब एंटी क्लॉकवाइज ट्रैवल करेंगे माइनस प्लस मिलेगा. बैलेंस विल बी देयर. बट अगेन ट्राई टू कीप योर assumptions as simple as possible. Now what is this? This is your trace direction. This is your trace direction. Am I here now? Okay. Now where I may be in the circuit, I may be in the circuit in the top, up or bottom. अगर मैं यहाँ पे हूं तो इट इज राइट. अगर मैं यहाँ पे हूं तो लेफ्ट. अगर मैं लेफ्ट में हूं अप, अगर मैं राइट में हूं डाउन. ये क्या होता है लेफ्ट एंड डाउन? बिकॉज व्हेन आई एम ट्रैवलिंग, जब मैं यहां से यहां ट्रैवल कर रहा हूं, वेयर आई एम ट्रैवलिंग अपवर्ड, यहां से यहां ट्रैवल कर रहा हूं राइट, यहां से यहां ट्रैवल कर रहा हूं डाउन. बट सबका डायरेक्शन एक ही है, क्लॉकवाइज. अंडरस्टूड? ओके. तो बच्चों, now I got a choice. Now I got a choice. I may consider this as negative, but compulsion, then I have to consider this positive. Someone may say, so I will consider this positive. In that case, what he has to consider? Negative. अब ध्यान से सुनना, this is very interesting. तो बच्चों, when I am tracing, how I am tracing? First positive, then negative. First positive, then negative. So I am traveling or tracing from higher potential to lower potential. So can I say fall in potential? I will assume fall in potential. I will assume negative. I'm traveling from positive to negative. I'm traveling from positive to negative. This is what I'm thinking. I'm thinking I'm traveling from higher potential to lower potential. So this is fall in potential that I will assume negative. So can I say this will be considered as minus V? What will be this IR will be considered as? Okay. When I'm tracing this type of voltages, I'm tracing or traveling from lower potential to higher potential. Can I say therefore, because यहाँ पे assume word आ गया, तो यहाँ पे क्या word आएगा? Compulsory. Now it is compulsory. Therefore, rise in potential. Now what is compulsion? It must be what? It must be what? Positive. So how this V will be considered? How this IR will be considered? So what is our convention? Fall in potential, negative, and rise in potential. Anyone, any doubt? Everyone
No,
getting this?
Yes,
Chalo, note down, note down. फॉल इन पोटेंशियल का मतलब क्या? हाँ, इसको पॉजिटिव बोला तो इसको नेगेटिव कर सकते। इफ यू assume this positive, this should be compulsory negative. Again, that is a choice. So what are the choices? गार्डन में कैसा ट्रेवल कर रहे, कैसा जॉग कर रहे, किसको नेगेटिव कहोगे, हेंस किसको पॉजिटिव कहोगे? इसको पॉजिटिव कह सकते हो, तो ये बन गया। ओके, okay, now one doubt from me. Is any relation between direction of current and positive and negative of voltage source and voltage drop? What my question? Question समझ में आया? Is any relationship between direction of current and positive and negative? What my question? मतलब जब भी आपको पॉजिटिव नेगेटिव दिखता है और जब भी करंट डायरेक्शन दिखता है, उसमें क्या गलती पॉसिबल होती है या क्या डाउट प्रोड्यूस होता है? Simple circuit. Okay. A, B, C, D. Okay. What current will flow in the circuit and what will be direction of current? This is positive.
Negative.
Current will start from positive and will come back to negative. Everyone agree with this?
Yes, sir.
Now this is direction of current. This is direction of current. Now still this is in my hand. कि मैं clockwise उसको trace करूँ या anti-clockwise trace करूँ. That is my choice. Understood? This is the direction of current. And what current will flow? 10 divided by 10. 1 ampere. Correct? Okay. What will be the polarity of voltage drop across 5? जैसे करंट एंटर करेगा पॉजिटिव, जैसे करंट निकलेगा नेगेटिव. So apply KVL to loop. Now this is my choice. Okay, I may say A, B, C, D, A. तो सोच के बताओ, am I traveling clockwise or am I traveling anti-clockwise? Clockwise.
Clockwise.
Very good. So this is 10 minus 5, 5 into 1, minus 5 equal to 0. Is it satisfying? Everything is correct? Fine, everything. Now tell me what is difference between this arrow and this arrow? This is the direction of current. And what is this? Trace direction. कोई बोलेगा सर हमने जो ये assume किया है उसको हम उल्टा assume कर सकते हैं? कर सकते हैं. In that case, what will be this sequence? A, D, C, B, A. What will be this? Plus 5, plus 5. Understood? KVL कैसे apply होता है?
So can you repeat this once more?
Okay. I can travel or can trace in the opposite direction. So apply KVL to loop A, D, C, B, A. What will be equation in that case? Plus 5 minus 10 equal to 0. Beta आया समझ में? Am I clear, beta? Okay.
Yes, sir.
Now my question to you people is, this is positive, this is negative, and current is going away. How come this is positive and this is negative and current is going inside? Because what is the rule? Current should leave positive terminal and enter negative terminal. Or am I doing some wrong comparison? Am I comparing to wrong quantities? What is this? This is the active element. This is the source which has got the capability to deliver current, and it will deliver current from positive to negative. And what is this? Voltage drop. It will always have power accepted. So understood this positive, negative, and this direction of current. Understood this positive, negative, and this direction of current. Don't only look at positive, negative. Look at, is it positive, negative of a voltage source, or is it positive, negative of voltage drop across a line? What is difference between this positive, negative, and this positive, negative? This is the polarity of voltage source, and this is polarity of a voltage drop. So don't get surprised if current is going inside positive terminal. Don't get surprised if current is going away from positive terminal. Both are correct. Understood? Note down. Note down. Good. Shaunak, I'm very happy with your answer. Every device should have liability or flexibility to draw its own current. That's why all the currents are in parallel. Okay. In this Kirchhoff's law, we talked about KVL. What should be next? KCL. So write down current law. Very good picture. Right? Kirchhoff's current law. Kirchhoff's current law. Kirchhoff's current law. ब्रैकेट में लिखना KCL. ब्रैकेट में लिखना KCL. Right? Algebraic sum of all the current, algebraic sum of all the currents meeting at a junction is always zero. Okay. जहां पे जंक्शन लिखा है ना, वहां पे और एक वर्ड लिखना. What is the word? Node. You can use any word. Or इसको एक और डेफिनेशन लिख सकते हैं. Sum of currents coming to the node is always equal to sum of currents going away from the node. Okay, bachcho,
Sir, can you repeat?
I'll repeat the second
Yes,
way
sure.
of writing definition. Sum of currents coming to the node is equal to sum of currents going away from the node. Am I right, bacha?
Yes, sir.
This is I1, this is I2, this is I3, this is I4. Okay. If I assume current coming to the node positive, can I say, am I right? I1 plus I3 is equal to what? Am I right? Matlab, I can write, this is the first way. These are the currents coming to the node. These are the currents going away from the node. Someone may say, I will think in this way, I1 plus I3 minus I2 minus I4 equal to 0. Now what he assumed? Current coming to the node is positive, current going away from the node is negative, and algebraic sum of all the current equal to 0. Just like you traveled or traced A, B, C, D, A. कोई बोलेगा मुझे उल्टा ट्रैवल करना है, तो is it correct? Will it be correct? कोई बताएगा? Okay. What assumption is hiding here? Current coming to the node is assumed what? Negative. Current going away from the node positive. Is everything same? But हमेशा याद रखना, this is the most safe way to do this. Because इसमें आपको पॉजिटिव नेगेटिव याद रखने का जरूरत नहीं. But अगर जरूरत पड़े तो ये कर सकते हैं. But if choice is there, I'll go for first. Because then I don't have to remember which is positive, which is negative. Understood? Okay, note down. Okay, चाहिए तो इसको भी नाम दे दो. Sign convention for KCL. Sign convention for KCL.
Sir,
Okay, someone is asking, sir, in today's long distance running trains, the current supply used is DC. That is why it's lack in instant torque to fans in coaches. No, bacha. SK, answer is not, or this way is not correct. We used to have DC trains because that time we used to use DC series motor, which are giving a very high starting torque. But compared to DC, AC has got advantage. So we are transferred from DC to AC. Now trains are running on AC because AC motor has got more advantage than DC. Am I clear, bacha? SK? हाँ bacha, someone is asked this dot. Very good.
Yes, ma'am. Yes, sir.
Okay. Yes, sir. Thank you. Do participate in the discussion. Do participate in the understanding.
sir, in KCL also it's our choice to assume the sign convention.
देखो ना, you can have this or you can have this.
No,
You can
because-
assume your choice. Because basic.
12th
bolo.
standard, because in 12th standard it was compulsory to assume that the current
coming towards the junction is positive and going away is negative.
But if someone is assuming other way, will it change anything?
No.
Okay, now you have got freedom.
Okay.
Okay, bacha. So, bacho, thank you very much for first half. So, exactly 10 minutes break. After 10 minutes, all the resistance, inductance, capacitance will come back and will get connected. Thank you very much. Am I audible? Hello.
Yes, sir.
Thank you. Thank you. Bacho, a very interesting situation I want to discuss with you and relate it with our syllabus. Suppose I have some electrical appliance, some electrical appliance, maybe geyser, maybe toaster, maybe anything. Generally, we have a coil there. Generally, we have got a coil there, and we have socket here. We have socket here. We have socket here. You have got a cable here. This is phase. This is neutral. And you are here as you don't have any work right now except going to FC. Very happy helping your mom. Okay. Now question is everything okay till now? Yes. Answer is yes. Everything is okay till now. Everything is okay till now. But I want to ask one question to you. If this happens, what may happen to you? What may happen to you? Shock. फ्री ऑफ कॉस्ट. आप लोग स्पाइस के लिए कितना खर्चा करते हो? देखो कितना सिंपल है. नाउ क्वेश्चन is any protection available for this? Is any protection available for this?
Insulation.
Very good. Insulation. Try to use some correct word.
Earthing.
Right. Very good. That is more correct word. So this is okay. What you have here? You have here this earthing, which is connected to ground. Okay, now tell me, current has got, this is earth fault. This is earth fault. Now question is, now fault current has got two choices. Either it can go this way or it can go this way. Which path current takes? It always takes this resistance path, and this is almost a zero resistance path, and it will be saved. So understood what this socket is? Is it a single phase supply or three phase supply? It is a single phase supply. Don't see three that particular pins and say that it is a three phase. No, it is a single phase supply. One is phase, one is neutral, and another is earth. One very interesting question to you. Why earth socket is bigger and the earth pin is longer? Understood my question? Why earth socket is bigger and why earth pin is longer?
So when you put the plug in the socket,
first contact
connection is made is the earth side.
Okay, we'll answer this question this way. The answer is on. जब हम लोग plug in करेंगे, when we'll plug in, which contact should happen first? It should be earth. Is it a preventive? Is it a safety measure?
Yes, sir.
Okay. Okay, ये तो हो गया. Why earth pin is longer? Now, can you answer the question why earth socket is bigger?
So बाकी का कोई उसमें fit नहीं होगा.
बराबर वही तो fit होगा. And having a more cross sectional area means you are having a small resistance, and none other pin will fit in that particular pin. Okay. So right now, concept of open circuit and short circuit. So there earthing is not required, but it should be there. It's always advisable earthing should be there. but somewhere you got only 2 pins. That is also there. Concept of open circuit and short circuit. Concept of open circuit and short circuit. Concept of open circuit and short circuit. Okay. Now this you are not supposed to draw everything, just you have to take the concept. Bacho, this is fuse. This is a single phase 230 volt AC supply. And what you have, either you have got fuse or MCB. Generally single phase जो तो MCB होता है. And you have got different load. This may be tungsten filament lamp. This may be some tube light. This may be tube light. So on. And you have got socket here. You have got socket here. जहाँ पे आप आपका charger या कोई भी movable load, electrical iron you can put here. Understood how this is working? Okay. अब ध्यान से सुनना. If this bulb is fused or burnt out, see the language, huh? Burnt out. What will happen? Is it this thing happen? Can I say open circuit will create? There is no current. What will be current here? 0. So in case of open circuit, what is current? 0. But voltage will be there. अगर आपने यहाँ पे voltmeter लगाया तो आपको voltage दिखेगा. You should take care. Even if when you are putting out the fuse bulb, you may get a shock because there is a voltage. There is a voltage. Understood? So write down. In case of open circuit, current will be 0. Current will be 0. But open circuit voltage exists. बच्चों ध्यान से सुनना. Now this is the most important point. Now you are doing practicals and the sockets are in front of you. You have got wires in your hand. The first thing comes to your mind, what will happen if I put this wire in this socket? ऐसा करने का नहीं. Okay, किया है कुछ लोगों ने. तो बच्चों सोच के बताओ, if someone do this, or suppose this happens accidentally. If this happens accidentally, what will happen?
Short circuit.
Short circuit. This entire resistance will become 0. Why? Because short circuit means it is a 0 ohm. There is no resistance here. Tell me R1 parallel, R2 parallel, R3 parallel 0. Anything parallel 0 is 0. R into 0 divided by R plus 0. So what will be total resistance? 0. Theoretically, what will be current? Theoretically. Practically, जितनी इसकी औकात है. What maximum it can deliver? Okay. Will it cause a great accident here? Because such a huge current will burn entire wiring. तो आपने सुना होगा, because of short circuit, this and this building caught fire. This is the reason. Now what happens? Now this is not done intentionally many times. There is old building, old wiring, phase and neutral going close to close. Over the period of time, insulation gets removed and phase and neutral gets connected, and this happens. Okay, is any protection available? If current goes beyond the limit, what should happen? MCB should trip or fuse should blow. MCB should trip or fuse should blow. Are you getting this word? Okay. So tell me, in case of short circuit, what will be current? Current will be maximum. So write down. In case of short circuit, maximum current will flow maximum current will flow maximum current will flow okay. Now I want to talk about this very interesting concept. Sometimes you will find that some element, though present in the circuit, is not being considered. Sometimes an element is there, but it is not being considered. It is not being considered. Why? We'll see the reason. Why? We'll see the reason. (10 volt), 5 ohms, 5 ohms. What current will be delivered by the battery? 1 ampere.
1 ampere.
Everything happening fine. Nothing, no problem. What happens if this additional thing happens here? Now, current drawn will not be 1 ampere, it will become 2 ampere. Why? सोच के बताओ. No current will enter through this. Because now when current comes here, it has got two paths. One is 5 ohm and one is 0 ohm. Which path it will take? 0 ohm. Can I say this has become redundant?
Yes, sir.
So whenever an element, especially resistance, is connected across a short circuit, it becomes redundant. Means it is not considered in the calculation. Many times it happens with you. You are present in the lecture, but you are redundant. Mind कहीं पे और है, मतलब girlfriend का ख्याल आ गया. Current goes through that girlfriend only. No current goes to your brain, and you become redundant at least for some time. So can I make this statement? Write down. Okay, write down. If a resistance is connected across the short circuit, if a resistance is connected across a short circuit, if a resistance is connected across a short circuit, it becomes redundant. It becomes redundant as it does not draw any current. As it does not draw any current. Okay. Second thing you may have heard. देखते थोड़ा सा याद करके.
Sir.
बोलो बेटा. Go ahead. Yes. Go ahead बेटा. Some doubt? Hello. He is disconnected.
Sir, definition फिर से repeat करेंगे जरा.
हाँ.
First part.
If an resistance is connected across the short circuit, if a resistance is connected across a short circuit, it becomes redundant as no current flows through that resistance. By the way, my name is Professor Javed Patel, Vidyalankar Institute of Technology. So if someone asks me which college you should take admission, you know what is my answer. Okay, but different answers can be there. From few years, 15-20 years, we are here. Okay, so someone asked this question, so I repeated the answer. So बच्चों अब ध्यान से देखना. Okay. Six, 4. What is 6 4 ja? 24. 12, 2. 24. Is it something very unique? Is anything? Is it a Wheatstone bridge or is it a balanced Wheatstone bridge?
Balanced
Okay. What will be deflection of the galvanometer you are connected in this branch?
Zero.
So this potential and this potential.
IG is equal to
same.
0.
IG equal to 0. So can I make one very interesting statement? पहले लिखो मत, बाद में लिखो. In a balanced Wheatstone bridge, galvanometer branch resistance can be considered redundant. मतलब अगर मैंने सर्किट को ड्रॉ किया, good understanding बच्चों, I'm very happy. So what is RAB? RAB equal to 12 plus 6, 18 parallel 6. Okay, what happened to this resistance? Ignored. Redundant. But what is the condition? It should be balanced. If it is not balanced, then star delta. Okay, so write down. In a balanced Wheatstone bridge, galvanometer branch resistance can be considered redundant. Okay, there is one more very interesting redundancy concept, but that after you understand a new thing, that is current source. So uske liye there is one more, but it will be coming afterwards. Write down now new title. Concept of ideal and practical voltage source. Concept of ideal and practical voltage source.
Sir, I have a doubt.
Go ahead, beta. Ask.
Sir, while explaining redundancy, if a resistance is connected across a short circuit, you said, right?
Correct.
So why just short circuit?
Because if this is the resistance, this is pi, this is 10 volt. If it is open circuit, there is no effect on the resistance. Still, it is the valid circuit. What the beta?
Yeah.
When this will get bypassed?
Oh, okay.
जब इसको bypass होगा, short circuit आएगा, तभी ये redundant होगा. Okay.
Okay.
Good beta. Good understanding. Now, the most important part.
So can you explain why it is balanced Wheatstone bridge?
In a balanced Wheatstone bridge, galvanometer branch shows null deflection because on each side, whatever voltage is there, it is equal. The potential difference is 0, and that's why that resistance can be removed. Am I right, beta?
Yes,
Hello?
sir.
Okay, बच्चा. बच्चों, कुछ चीजें मैं ड्रॉ करता हूं, शायद आपको थोड़ा सा याद आए what I am talking about. This is V, this is R, or I may have this symbol. This is V, this is R, or I may have this symbol. So basically, this is 1 unit. Basically, this is 1 unit. This is not connected externally. This is not connected externally. This is part of a package. This is a part of package.
So they are
Okay.
same thing.
Same thing. All the three are same, but represented by different symbol. At your level, कोई भी symbol आया तो तीनों का symbol मतलब it is a voltage source. It is a voltage source. Now question is, what is this small r?
Internal resistance.
It is internal resistance of voltage source. It is internal resistance of voltage source. What should be its value and why? What should be its ideal value and why? Okay. इसके लिए जब भी ऐसा क्वेश्चन आता है, we should experiment. ऐसा नहीं कि experiments are only there for the sake of experiment. Experiments are there to know this type of things. I want to know what should be value of small r ideally, so I get best result. So that I get best result. अब ध्यान से देखना. I will draw here VI characteristics for a voltage source. Okay, what I mean by VI characteristics? I will apply some load. I will apply some load. Stop talking, Bicha. So I will draw some current from this voltage source. I will draw some current from this voltage source, and then I will check the output, which is the voltage of a battery, which is the voltage of a battery. What should happen ideally? Whatever load I'm connecting across this battery, it should deliver me a constant voltage. So this is what ideally should happen. This is what ideally should happen. But practically what happens? As you go on increasing the load, जैसे जैसे आप बैटरी पे लोड बढ़ाते जाते हो, voltage drops. Now this is what? Practical. This is what? Practical. Now, can anyone tell me what is this drop? This drop is a voltage drop. This drop is a voltage drop, and this is equal to I into R. This is equal to I into R. Okay. If I want I into R 0, if I want I into R 0, what should be value of R?
0.
So can I say R should be 0 ideally? R should be 0 ideally. Now nothing is ideal in this word. Nothing is ideal in this word. Can I say R should be as small as possible? Practically
negligible.
It should be negligible भी नहीं हो कर सकते हम लोग उसको जितना छोटा कर सकते हैं, मतलब मैन्युफैक्चर करते वक्त, but we cannot make it 0. We cannot make it 0. Understood this? मतलब in case of voltage source, the internal resistance of voltage source should be ideally 0, practically as small as possible. बाद में मैं टाइम दूंगा लिखने के लिए, थोड़ा वेट करो, सब लोग साथ में लिखो. Anyone any doubt about this? Anyone any doubt about this? Okay. Now, like a voltage source, at least some part we have to think about one more source known as current source. Okay. Now this you can go in the market and buy. Give me a battery pack for my mobile phone. Give me a battery for my remote control, like that. But this something is not readily available in the market. This you have to design in electronics lab. So see what is the title? Ideal and practical current source. What is the concept? Concept of ideal and practical current source. तो बच्चों this is I and this is R, और जो बचा हुआ है that will be delivered to the load. Okay, this is V, some drop across resistance and remaining voltage will be delivered to the load. Okay, ideally what should happen? There is a battery of 5 volt, that R is 0, so nothing is dropped internally and all 5 volt is available for load. All 5 volt is available for load. Can you see a series circuit? V, R and RL. RL is very happy. Kab happy? If small r is 0. Because usko pura ke pura uska voltage milega. But at least what he will request, try to keep small r as small as possible. So 5 volt minus 0.1. Okay, 4.9 volt is a good voltage. That is what your mobile phone battery should be. Agar it is of 3.7 volt, then if it is dropping to 3.65, okay. But if it is dropping to 3.5, 3.4, bad. Because if voltage drops, current will increase. Power will remain same. It will heat up. That is what duplicate battery do in your mobile phone. See, it is a very important thing. हमको क्या लगता है? अरे क्या फर्क पड़ता है? डुप्लीकेट डाला तो वही तो सब तो काम करता है. नहीं, आपका मोबाइल खराब होता है. क्यों खराब होता है? There is a considerable amount of high value of small r. आप बोलेंगे उससे क्या होगा? 3.7 minus that drop. What is available? Maybe 3 volt. 3 volt into I. Power तो उतना ही लगेगा जितना आपके मोबाइल को चाहिए. So what it will draw extra current? Will it damage mobile phone? Okay. Now question is same way. Same way. Just a minute. But you can draw this. Please draw whatever written on the board. हाँ कोणी सांगितलं ग्राफ कैसे आया ए हाँ 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 आई एम गोइंग टू रिपीट आई वेंट आउट ना ओनली दिस मच स्टिक टू दिस मच load LOAD
Sir, in that graph, voltage is varying with respect to current or load.
both are same. When you are saying your load is increasing, means current is increasing.
Okay.
both are same. Current is representing load. Current is representing load. Okay, when you finish this, I will have one very practical question to you. Which mobile phone has a better battery? I will name the device. You try to tell me. देखो 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 सुनो पहले. iPhone 14 Pro Max or S23 Plus Ultra or S23 Ultra. Okay. Now you are talking this in terms of what? Battery life. Okay. But within that, it gives you better performance. अब question is, अगर दोनों का बैटरी निकाल के आपको दिया, if I give both the batteries to you, and by using this concept, you are supposed to tell me which battery is better. Now don't think about how much duration it is giving. What is talk time? What I'm interested in? Okay. ऐसा कुछ है कि durability of iPhone or Apple product is greater than all other products? Only just giving indication. मतलब जहां पे ऐसा concept आएगा, वहां पे they are doing better. वहां पे they are doing better. Now I will not say iPhone or Samsung. I will say battery 1. I will say और ले लेते and if you perform the experiment in the lab, आपको क्या करना पड़ेगा? See, ध्यान से सुनो what you have to do. You have to take a battery and connect a load. Some bulb you have to buy. Bulb of 3.7 volt or 4 volt जितना वो battery है. And go on connecting them in parallel. If you don't connect any bulb, voltage will be 3.7 volt or 4 volt. But if you connect first bulb, it may drop a little bit. If you connect second bulb, it may drop. Means, are you increasing load? Are you increasing current? Okay. अब ध्यान से सुनना. This is ideal. This is ideal. So this is V. Maybe 3.74 or 4.5. What is this? The number of bulbs you are connecting. Suppose this is giving you this graph. And this is giving you this graph. Samsung is giving you this graph. And iPhone is giving this graph. Now tell me which battery is better and why. Why?
iPhone only.
Why?
Voltage drop is less.
So can I say small r is less? Can I say small r is less? Is it an advantage? Why? What? Because it will draw less current. Heating will be less. That is the main problem with this device. Okay, so why we do practicals? जब भी हम लोग मैकेनिक्स के BEE के प्रैक्टिकल्स करते हैं, then you have to write conclusion. तो हम लोग का conclusion क्या होता है? Hence verified, hence done. नहीं. Now you should able to write this. You should able to write this when you do your practicals for BEE. Anyone any doubt about this?
Sir, here we are connecting the loads in series.
Parallel. Okay, this is a question. Are we connecting load in parallel or series? Parallel. Then only current will go on increasing. Am I right, beta?
Okay, yeah.
Okay, bacha. Okay. Your question. More ideal. It is going towards, because I want actually what I want. Ideal. जितना ideal होगा उतना Okay. Now this is what practically you should do. अब बच्चों ध्यान से सुनना. Okay. Now R is internal resistance of current source. R is internal resistance of current source. अब ध्यान से देखना. I want to know what should be value of R. See, what is difference in this R and this R? This we represent in series and this we represent in parallel. अब ध्यान से सुनना. This time load will be voltage. This time load will be voltage. And what is output? Current. Ideally, what should happen? What do you mean by straight line?
Ideal case.
Whatever may be the voltage applied to the current source, zero, medium or maximum, it should deliver same amount of current for which it is designed. Now nothing is ideal in this, what we know. Tell me practically what will happen. There will be some drop. So this is practically. Okay. Now this was voltage drop. What will be this? What will be this? It will be current drop. This will be current drop. Is it equal to V upon R? What was equal to? I into small r. This is voltage. Ohm's law. By Ohm's law, what is current? V upon R. अब ध्यान से सुनना. To get that ideal graph, V by R should be 0. So what should be value of R ideally?
Infinite.
Infinity.
Very good. So R should be, very good answer. R should be infinity. Ideally. What should be R practically?
Maximum.
R
Very
should
less.
be
Maximum.
less और बहुत ज्यादा चाहिए ना? Should be as high as possible. Note down, and if any doubt, let me know. Note down. Your understanding is very good. I'm very happy with the way you are interacting. You are putting your opinion. You are not shy. Now this you have to continue till oral, because somehow there is some comfort zone with me, but same comfort zone you have to create with your teachers, because whatever questions will be asked after each practical, you should go to this depth. Do ask any doubt to me and should able to answer this type of questions confidently, so that definitely you will get a very good pointer in all the three aspects: internal assessment, in term work, oral, and in EAC. For EAC, it is 32 marks out of 80. For internal assessment, it should be 8 out of 20. And when it is 25, it should be 10.
Sir, can you again explain the graph variations?
Graph? Which graph, bacha? Last graph?
No. दोनों graphs.
हाँ बच्चा, बच्चों, when I am putting VI characteristics of a voltage source, what I'm doing, I'm taking a battery and connecting bulbs in parallel. Connecting bulbs in parallel. With every new bulb connected in parallel, what I'm going towards? I'm going towards right part of the X. I'm increasing load, 0.1 ampere, 0.2 ampere, 0.3 ampere. Okay. When no bulb connected, both graph will be having the same point. But in ideal case, कितना भी लोड में कनेक्ट करूं, कितने भी बल्ब्स में कनेक्ट करूं, कितना भी करंट में ड्रॉ करूं, voltage remains constant. But practically it does not happen, because practically some small r is present in that battery. So it will drop, it will absorb the voltage. So what this small r is doing, it is reducing the voltage delivered to the load. So what is the graph? Graph will be drooping. Graph will drop. Okay. Same thing happens here. Ideally, constant current is delivered by the current source. But practically, as you go on increasing that particular voltage, that particular current goes on dropping. Am I right, bacha? Hello? Hello?
हाँ sir. Yes sir. Yes.
Okay. Okay. So thank you very much for. आज हम लोग इधर ही रुकेंगे. Thank you.
Sir.
हाँ बोलो बेटा. Just a minute. हाँ. Go ahead, बेटा. Any doubt?
Statement where the bulb, when we connect it in parallel, the voltage remains the same is wrong, right?
Voltage will go on dropping, na?
Yeah. Okay.
Okay. Any doubt? Any point? Anyone? Because we are stopping here.
No, sir.
Thank
Sir,
you very
can you
much.
repeat all the marks once again, please?
Just a minute. Just a minute. 80 marks end semester exam.
80
20 marks end semester exam. 20 marks internal assessment.
Internal assessment.
25 marks term work.
25 marks term work.
Term work. And 25 marks oral.
Okay. Thank you, sir.
Thank you. Okay. Someone go and please bring receipt. किसी का receipt बचा है तो. Otherwise you can read.
Sir.
Thank you. Okay, 1 minute. 1 minute. Saturday you have to bring calculators with you, because without this we cannot solve the questions.
Sir.
हाँ बोलो. Go ahead.
सर इंटरनल असेसमेंट के मार्क्स एज अ जीपीए में जो हमारा फाइनल में निकले उसमें काउंट नहीं होगा ना?
नहीं उसमें भी होगा ना. टोटल इसमें होगा ना. तुम्हारा जो काउंटर आएगा उसमें रिफ्लेक्ट करेगा ना. इट शुड बी 20 आउट ऑफ 20 बेटा. थिंक ही नहीं, सोचने का ही नहीं.
ओके सर.
ओके. हाँ गो अहेड बेटा.
सर ये टॉपिक 80 आउट ऑफ कितने मार्क्स के लिए रहेगा?
दिस टॉपिक विल बी अराउंड 35 to 40 marks.
Okay. Thank you.
But paper will not be 80. With option it becomes 120 around. आया समझ में बच्चा? There are some options also, ना? Extra questions. Internal assessment या oral में अपने जैसे यूनिट टेस्ट होता है. नहीं it is pre-planned. Will be told you कि after 1 month, 1.5 month test will be there and they will. नहीं वो अलग होता है. सरप्राइज मतलब. Anyone any doubt बच्चा? हाँ आ जाओ. हाँ पेन इधर चले. पेंसिल सर. हाँ पेंसिल है. हाँ गो अहेड बेटा.
वो कैलकुलेटर्स के नाम बताएंगे फिर से आप?
991 ES और 991 EX.
ओके सर, थैंक यू.
हाँ ये क्या किया जाता है, एक टर्मिनल बड़ा होता है उसको ग्राउंड किया जाता है. तो इन केस दिस हैपेंस, instead of it going through person's body, it has got no option. What option it has? Earth. This is earthing terminal. Ideally it has got zero resistance. So which path current will take? Now two paths are possible. Current can go to human body or current can go through earthing. It will go like this, so no current will go here. Now, यहाँ से ground को जाने के लिए इसके पास दो option है. Either it can go through your body, or it can go to zero resistance path. It will, which path it will take? हाँ, कहाँ पे? ये क्या है? ये body है ना? This is the appliance body. Resistance नहीं लगा है, but it is a zero resistance path.
फिर अगर शॉर्ट सर्किट हुआ तो फिर वो रेजिस्टेंस करेगा
A5. तो हाउ करंट विल गो? दोनों रेजिस्टेंस में से जाएगा. करंट अभी ऐसा जाएगा. व्हाट इज करंट? 1 एम्पियर. बट अगर शॉर्ट सर्किट हुआ, व्हिच पाथ इट करंट विल टेक? It will not take this path. Current will go this path. To what resistance it will experience? Only 5. What current will be there?
2 amp.
शॉर्ट सर्किट मतलब इसके अक्रॉस वायर आ गया.
हमेशा रेजिस्टेंस 0 होता है.
तो करंट विल गो थ्रू वायर.
रेजिस्टेंस का पाथ है, तो 5 और 0 है, सो मिनिमम 5 है ना, तो इसलिए 0 से. मुझे लगा कि यहाँ से जा रहा था, तो फिर मैं बोला कि ये भी पार्टिसिपेट कर रहा है.
नहीं कर सकता ना. इसका ऑप्शन था, करंट को ऑप्शन है ना. Either it can go through 0 or it can go through 5. It will go through 0. नहीं तो नॉर्मल सर्किट. This is the normal circuit ना. It is active. When it will become redundant? जब यही सिचुएशन. चलो, थैंक यू बच्चों.
यस सर.
Okay, anyone, any doubt or online people?
No, sir.
I'm still here. हाँ बच्चों लोग, कैलकुलेटर का नाम मैंने 991 ES plus और 991 EX. Without fail, bring your calculators. जावेद पटेल. हाँ मतलब ये सेम है क्या? Okay. Now there is a battery and resistance in series. There is a resistance and series with the battery. Both are same. In series आप कोई भी चीज पहले ड्रॉ करो तो फर्क नहीं पड़ता. इसलिए मैंने जानबूझ के पहले रेजिस्टेंस ड्रॉ किया, बाद में बैटरी ड्रॉ किया. यहाँ पे क्या किया? पहले बैटरी. इट डजंट मेक एनी डिफरेंस बिकॉज सीरीज में करंट तो सेम रहता है. अगेन सी द डिफरेंस इन द सिंबल. यहाँ पे सिर्फ दो पॉजिटिव निगेटिव दिखाया, यहाँ पे मल्टीपल पॉजिटिव निगेटिव दिखाया, और यहाँ पे मीनिंग ऑफ दिस 3 इज सेम. इट इज अ वोल्टेज सोर्स. पैरेलल में हम लोग अब मैटर करेगा ना, करंट अलग अलग ड्रॉ होगा ना. जब सेम करंट ड्रॉ करता है तो
पहले बैटरी और रेजिस्टेंस में क्या कैसे क्या डिफरेंस?
अलग अलग करंट ड्रॉ करेगा ना. वहां पे तो जैसा कि अभी यहाँ पे है, इट डजंट मेक एनी डिफरेंस. बट यहाँ पे अगर तुमने वी लिया, बैटरी लिया और रेजिस्टेंस लिया, तो पहले तुम क्या ड्रॉ करोगे उस पर डिपेंड करेगा. Thank you very much. Learned and enjoyed a lot today. Varnika, thank you very much. Thank you. Keep asking question. Keep learning. Bye, Bachor. Bye.
Bye, sir.
Bye, bye,
Thank you, sir.
Bye. Thank you.
Bye,
Thank
sir.
you. Thank you.
Thank you, sir.
Thank you. Thank you very much.
Thank you, sir.
Thank you. Subodh, you can stop the meeting. Subodh, Vaibhav.
Yes, sir. Thank you.
Thank you. Thank you very much.